What's up, guys? Thanks a lot for tuning into my talk at DockerCon 2020, and I hope that you're enjoying the virtual experience so far. I'm going to be talking to you guys about building and deploying a multi-container application to AWS. In case you're wondering what inspired this particular talk, well, the portability and consistency that you get with Docker, which is absolutely fantastic, is like a journey that feels somewhat incomplete till you actually see your local Docker container or containers shipped off into a production-like environment. And so I thought, what better way to do that than actually deploy an application into the cloud, in this particular case, AWS, and we can take the whole journey from point A to point Z and you can get a hands-on feel with that. My name is Lukonde Mwila, but a lot of people call me Luke. I'm a software engineer and I work for a software company called Entelect Software in South Africa and consult at Standard Bank SA. Let's take a look at our project in a picture. So this might appear intimidating at first glance, but let's piece it all together. On the left-hand side over there, we've got our CI/CD pipeline, and for this, we're making use of Code Pipeline, which is a CI/CD tool or a service offered by AWS, and it's got three stages: source, build, and deploy. The source stage pulls our source code from a GitHub repository, and in the build stage, what we're going to be doing is we're going to build our Docker images, and we're going to run some tests on the containers from those, and if we're happy with the tests, that is if they pass, then we want to push through those images over to Docker Hub. The step after that will be the deployment stage, and we're using Elastic Beanstalk as the provider for this. Now, Elastic Beanstalk has a whole lot going on under the hood, but it abstracts all of that away from you, making your life a little bit easier. One of the services that Elastic Beanstalk uses under the hood is ECS, in the case that you want to be able to deploy a container or multi-container application. Now, ECS is a platform that allows us to do just that. So now I'm going to ask you to shift your eyes over to the right-hand side. And what's going on over here is there are three containers that we're going to be deploying into AWS. Locally, we're going to have a fourth one, which will be our MongoDB database. But when we move it up to the cloud, we're actually just going to use MongoDB Atlas instead. Now, for these three containers, the first one that you'll notice may be the Nginx proxy container, and this is just going to proxy any incoming requests over either to the client container or the backend container. Our backend container is what's going to be connected to MongoDB Atlas. The little cherry on top over here, not really necessary, but I thought it would be a sweet addition, is pushing through notifications of the pipeline state changes to Slack, to a specific Slack channel that is. Now, what we're using for that is Amazon CloudWatch, which will receive any state changes in Code Pipeline, and CloudWatch then targets a particular Lambda function. That Lambda function will then push through certain notifications to the Slack channel. I should mention right from the onset that the source code for this entire application, along with the infrastructure, is already available in a repository on my GitHub account. I'm using Terraform for the infrastructure as code, so please do feel free to go and clone that, and it might work as a great jump start for you for this very walkthrough or for any similar projects that you may want to run in future. Now we turn our attention to Docker Compose, and indulge me as I go through a bit of theory behind it. After that, we will get our hands dirty and spend a bit of time building out our actual Docker Compose YAML file for the different containers that we're going to be getting up and running. So Docker Compose is a separate CLI tool. It's really helpful when it comes to running multiple containers at the same time. You can use it for a single container if you like, but it just really helps eliminate you having to run a lot of the repetitive commands that you'd have to execute when using the Docker CLI. So it's really helpful in issuing the same CLI commands, but doing it in a more efficient manner. Now, outside of Docker Compose, the containers that you run don't have any automatic communication. They're basically isolated processes. In this image over here, you'll see that there are 4 containers, and these are the 4 that we're going to build out. And each of them is a separate process, but we do want them to be able to communicate. Like I showed earlier, our Nginx container is essentially going to be proxying requests through to the client, which is React, and to the backend, which is Node.JS. And not only that, our Node.js container also needs to be able to communicate with our database, which is MongoDB in this case. Now, we could solve this by actually setting up the networking infrastructure. And for that, we would have to use the Docker CLI because it has networking features. That can be a bit of a cumbersome process. Instead, we're going to be using Docker Compose because it takes care of all of that for us automatically. So let's actually now start building that out. And I think when you get a taste of it, you're really going to like it. All right. I should say, if you do hear any random cawing in the background, that is not the sound of our national bird. I like to believe it is the most hated winged creature in SA, the hadida. And I get a lot of those where I live. So just ignore that if you hear it in the background. We're in our Docker Compose YAML file. And this is essentially a configuration file where we specify our different services, and the services are the container types that we want to get up and running. We also specify our networking and our volumes in this very file. And we start off by being specific about the kind of version or the file format that we want to work with for Docker Compose. And so I'm using version 3.3. There are higher ones. You can go ahead and do that. And then under that, I start to specify my different services. And if you think back to the diagram that I just showed, our project in a picture, you'll remember that there are three main containers that we want to deploy, but locally we're going to have a fourth one, which is our MongoDB container. And so I've got Nginx, client, backend, and Mongo. Let's take a look at the first one, which is Nginx. And in here, I specify the build configurations that I want to be applied at build time. And so I want to build my Nginx container from a specific Docker file. And so I specify that over here. And this is the name of the Docker file that I use. And then the context is just where this file can be located. And it's going to be located inside of my Nginx container or directory. And then I specify the port forwarding, which is from localhost to container. And I'm using port 80 for that. Now, you'll recall that I said that this Nginx container is what's going to be proxying requests through to the client and the backend. So it is the single entry point for our entire application. So without this, then no one can get to our client or our backend. Underneath that, you'll notice that there's very similar configuration. The only difference in this particular case is I don't specify any port forwarding. And the reason for that, like I said, is because we have a single entry point. I did add the lines over here and commented them out in case you want to be able to get it up and running in isolation. And the container name for client, I specify as client. And I do the exact same with backend as well. I specify the container name for that as well. Now, you'll notice that there's an additional property over here that isn't in the previous ones, like Nginx and client, and that is the env file property. And that's if you want to add environment variables from a specific file. Alternatively, you could pass your environment variables in this Docker Compose YAML file, and you would use the env property like that. But I prefer to work with env files just because I can have them in my directory and I can add them to git ignore so that they never get committed to source code. And in this environment variable file, just for some context, is the connection string to the database. And so it's an environment variable called to-do-db, and it is located inside of a folder that I've called env, which is over here. And you'll see there it is, backend.env, and it's the connection string to our MongoDB. I'm going to close that. And then, last but not least, let me collapse this, is our Mongo container. And so I'm calling it Mongo. And the difference now is for the build configuration that I'm applying, I want it to build from an image as opposed to a Docker file. And so I would advise that you go ahead and just pull this directly from Docker Hub so that you can have it locally. And then what would happen is when you use Docker Compose, then it will pull this from your local cache for Docker as opposed to having to pull it from Docker Hub, which can take a little bit of time. And then I specify the container name just like I did with the previous ones. I go on and put the port range as well for our database. Now, another property here that is different from the others would be volumes. And volumes is a great way to persist data in containers. You hook up a file folder on your local machine to your container. And what I'm doing over here is I want to be able to persist any data from my Mongo database into my local folder. And so I'm doing that using a folder called Mongo volume inside of a DB directory. So if you want to see what that looks like, I've got my DB directory over here, and inside there is Mongo volume. And that's just a cool way to persist any data from your container. And in addition to that, remember that when you're running your database with Docker Compose, it will go through an entire initialization process. And so one of the things that you'll be required to pass are environment variables for a MongoDB super user, as well as the name of the database. And you could pass those here. In my case, I am passing them through as an environment variable file. As you can see over here, mongo.env, located in that same env directory that I showed you guys earlier. And in addition to that, I also want to create a user at initialization. And so I'm doing that using a file called initmongo.js, and that is going to be copied over into this folder which will exist inside of the container called docker entry point initdb. And I copy over this file in there so that it can be used during the initialization process. I set it to a read only, and so this way I want a user to be added when the database is being created. If you want to see what that file looks like, I'm going to head over to db initmongo.js, and I'm just creating this username, password. I give it a specific role and the database that I want it to be added to. And when that user is created, we can then use those credentials in our connection string in the environment variable for the backend. So that is our Docker Compose YAML file. Now that we're happy with our Docker Compose YAML file, we're going to move on to the different services that we defined in it. And we're going to start off with Nginx, and then we'll move on to the others, and we're going to be creating the respective Docker files that we actually specified in the Docker Compose YAML file. So let's move on to that. Before we get to our Docker file for the Nginx image, I'm going to quickly take you through a bit of the custom configuration that we're adding to our Nginx server. So if you recall the role that it's going to play in the bigger picture, we start off by setting up a virtual server, and we wanted to listen on port 80. And then we also add some routing rules that will define how the server should respond based on the incoming requests. If it is a request for the backend, then those requests should be proxied or forwarded over to our backend upstream server, and the same thing with the client in the case that it is a / request that comes through. And you'll see over here we've defined our upstream servers and we specify what should be targeted. Now if you think back to the Docker Compose YAML file, we had created our services with host names, backend and client, and these are the specific ports that those respective hosts will be running on. Our client or React application is running on port 3000, and our Node.JS application is running on port 3001. You may notice this command over here and wonder what that's doing. We're simply getting rid of the backend prefix that will come through in the request. The only reason we have the backend prefix added there is just so we know how, just so Nginx can know how to respond to that particular request. Moving on to the more important part, our Docker file. We're making use of the Nginx image from Docker Hub, and then we let it know that we are adding port 80 over here. We're exposing it, and I should just mention that this doesn't publish the port. This just tells Docker which port the container is actually going to be listening on, and then we remove the custom HTML files that will be in Nginx by default. And then we copy over our custom configuration that we just added. If you want to see exactly where that lives, inside of the Nginx folder, there's a configs folder which has default.conf, which we just looked at right now, and that we want to copy over into our image. And then lastly, our command execution is that we want Nginx to run in the foreground. Next up, we want to containerize our React application. And to do that, we're going to create two Docker files. So the first one being the one that I'll refer to as a production grade Docker file, which is the very one that we have specified in our Docker Compose YAML file earlier. The second one, which we'll save as dockerfile.dev, is going to be used to run tests in our build stage when we get to our CI/CD pipeline. So let's go ahead and create these two Docker files. So we're inside our dockerfile.dev, And this file is the one that's going to be used to create the base image that will be used to create a container specifically to run tests for our React application. I start off by specifying the base image, and this is the particular version of Node that I'm going to be using. And I go ahead and I define the working directory inside of the image, and then I copy over the package.json file, which is going to be which will contain all of the package dependencies. And then I go ahead and install those dependencies, and then I copy over the project content. And in this particular case, my package.json file has a script command for specifically for running tests, and so I run npm run test. Now, our production grade Docker file doesn't look that different from it. We still follow the same steps in defining our base image, the same working directory. In this particular case, I'm copying over both the package.json file as well as the lock file. And then I go through the normal process of installing the necessary dependencies, copying over the project content. But this particular file is a multi-stage file. And so I build the React application. And so all the content of our React app will be stored in a folder called build, and that will be inside the working directory. Now, I want to serve all the static content from my React application through an Nginx web server. So the second stage is to make use of the official Nginx base image. And then in this case, I'm exposing port 3000 because any traffic coming through from the Nginx server will be forwarded to this client, and it'll be listening on port 3000. And then I'm also copying over some custom configuration that I've added in a default conf file. This lives inside of the client folder, and you can take a look at the default configuration over here. And I create a virtual server like I did before, but this time I simply say that I'm listening on port 3000 for any incoming requests. And then I define another routing rule over here, and I also specify the root directory, and it should look for any files, in this case index.html, or any index file, because our React application is going to be injected inside an index.html file. And once I've done that, I copy over all the content from the build into the specific Nginx HTML directory where our static content will be served from. All right, and the next step is to containerize our backend, which is a Node.JS application, and I'm making use of the Express framework. So let's go ahead and do that now. So we turn our attention to the back end, and you'll notice that both the Docker file and dockerfile.dev don't look that different from the Docker files we created for our React application. We go through the exact same steps. The only thing that will be different in this particular case is we're exposing port 3001 because our backend is listening on this particular port. So I go ahead in the dockerfile.dev. Our command will be npm run test because we simply want to run tests on our Node.js application. The production grade Docker file only differs from it in that we are starting our application by running npm run start. So not much of a difference from the React Docker files that we created, except we are running this on a different port, and so we expose that. Finally, we get to bring it all together. Tie up a couple of loose ends, and then get our multi-container application up and running with Docker Compose. At this stage, we've got our Docker Compose YAML file, and we've also created each one of the respective Docker files for the services that we want to get up and running. All that's left to do is run the Docker Compose up command, and that will start up each one of the services that we've defined. Now, if you wanted to simply build the images, then you would run Docker Compose build. So I've already gone ahead and done this. My application is now running. Now, I should mention that this entire app is a basic to-do application. And so the front end is simply fetching items from the database. We can't add anything. So what I did was I run the back end as well as our database in isolation. So that is, I removed these two services and I opened up the ports, the port forwarding for the back end, and I made use of Postman to simply add some items to the database so that we can see that things are actually coming through correctly on the front end. I've already exported this Postman collection, multi-container to-do app, and it is in the repository that I showed right at the start of the talk. So that could save you some time. You can simply install Postman and import that collection. Here is our application running locally, and it's doing exactly what we want it to do, meaning our Nginx container is successfully forwarding traffic through to the front end, and our front end can successfully make a request to the back end, and the back end pulls the necessary data from the database. And these are the to-do items that I've listed: eat, code, sleep, repeat, and watch every DockerCon talk. We are just about to wrap up. The last things that we need to do are configuring our build spec YAML file for the build stage, and then we're going to configure a docker run.aws.json file, and this is a specific file for Elastic Beanstalk, which will specify how we want to deploy our containers, and that will be passed on down to ECS. And then we will set up the environment variable in Elastic Beanstalk, and last but not least, we will trigger our pipeline. Now that we've got our multi-container application running successfully on our local machine, we can take the next step, which is to deploy it to the cloud. And as I mentioned earlier on, I'm deploying this to AWS, and I will be using Elastic Beanstalk as the service or platform to run my application. Elastic Beanstalk uses ECS, which is Elastic Container Service, under the hood, and so we will have a specific EC2 instance with the necessary configurations and installations for our containers to run successfully. Now, I've already gone ahead and created a CI/CD pipeline using Code Pipeline, and on the build stage, I'm making use of Code Build, and I specify that I want to use a build spec YAML file to configure my build stage. So this is the build spec YAML file that we have over here, and I'm going to walk you through it. I specify the particular runtime that I want for the container that's going to run during the build stage. And then I've got different phases, which is the case with your build spec YAML file. You've got different phases with the commands that you want to run. And so in the pre-build stage, what I'm doing is I'm building my images, specifically the ones that are to run tests. So those are the ones with the .dev extension, both from my client and from my backend. And during the build phase, I run the containers and carry out the necessary execution commands so that the tests can be run on these containers. And if we're happy and the tests pass, then we go and build our production grade Docker images, and I sign into my Docker account, and in the post-build phase, I push these images through to Docker Hub. Now, the reason why that's important is when we deploy our application with Elastic Beanstalk, we're going to configure it in such a way that we want it to pull the images from Docker Hub. Now, over here, we've got our docker run.aws.json file. If you've ever worked with ECS, then you'd be familiar with a file that is very similar to this one that essentially describes or defines how you want your images to run or how you want your containers to be deployed on the application. And so this one is specific to Elastic Beanstalk. Some people like to refer to it as a super Docker Compose YAML file. You may notice some similarities in the structure, but this is a JSON file, whereas the Docker Compose one is a YAML file. So in here, we've got 3 containers that we want to deploy. We're not concerned about deploying the Mongo container because, as I mentioned, we'd be using Mongo Cloud Atlas when we deploy this. And so the 3 containers I'm defining here are the Nginx container, client, and the backend. And so I start off by giving my container a name, and then I add the image name for the online repository that I want my image to be pulled from. So this is stored in my Docker Hub account, and therefore it will pull it'll pull the image from this particular repository. And then I go on and add a host name, and I set this particular container as essential, which means I want the task to stop in the case that I run into any issues with this particular container. The reason why this one is essential is because it's the entry point for the other containers that are going to be running on the EC2 instance. If the client was to fail or the backend was to fail, our application can still kind of work in that we'd still be able to access it through the entry points of Nginx container. But if this one fails, then we can't reach our client or our backend. So only this one is set to essential. I go ahead and I define the port mappings, and you could probably figure out what this one does. It works similar to port forwarding, and so I open up port 80 because that's where we want traffic to come through, and I link this particular container to the client in the backend, and so it'll be able to discover them and communicate securely with these 2 containers. And the memory is going to depend on the particular EC2 configurations that you have or specifications for the particular machine, you can definitely do research on that one for yourself. So these two files are essential and needed. So when you've got them in your application, you can push your code. And if you are working with a CI/CD pipeline, then you would definitely need your build spec YAML file if you're using code build. In the case that you're not, all you would need is this docker run.aws.json file, and you can zip up your project and upload it straight to Elastic Beanstalk. Let's head over to the cloud. As you can see over here, I've already run my pipeline and it passed successfully. And so when you come here, this is the domain name that has been generated for me by AWS, and my application is running as expected. And so I did add an environment variable called to-do-db in Elastic Beanstalk and put the connection string for my Mongo Cloud Atlas DB, so don't forget to do that. And the last thing to show you guys would just be the little cherry on top that I was pretty excited about, the notifications that my Lambda function pushes through to Slack. That shows the pipeline started successfully, and it also successfully deployed our application. Thanks so much for tuning into my talk, guys. I hope it was of great value to you and your time, and I hope you enjoy the rest of the DockerCon 2020 experience. Till next year.